Welcome to the deep dive. Today we're diving into, well, the incredibly complex world of economics, where everything moves and shifts. Individuals, governments, businesses, banks, they're all interconnected, like pieces of this giant, intricate puzzle. The big question, really, for anyone trying to understand this stuff, is how do you even begin to predict what happens when you tweak just one small thing, let alone multiple things at once? And that's where artificial intelligence is stepping in. It's acting as this powerful computational tool capable of untangling these immense, constantly shifting, sort of large-scale challenges that define our modern economies.
Right. And while AI clearly holds immense promise for this, existing tools for economic simulation have been, well, quite limited, historically speaking. They've often simplified scenarios to what feels almost like a cartoon-like level, or they narrow their focus way down to just one tiny aspect, like maybe a single type of tax. They've really struggled to capture the full, messy complexity of the real world.
Okay, so our mission for this deck dive is to explore a new platform called EconGym. It's designed specifically to bridge this crucial gap, allowing AI to tackle truly complex, real-world economic challenges and maybe help us finally understand that bigger picture. So to really appreciate what EconGym brings to the table, maybe let's first shine a light on where these current AI economic simulations have historically fallen short. You said cartoon-like. What were these older models fundamentally missing? Was it just like overly simple assumptions, or were there key bits of the economy they just couldn't replicate?
Yeah, cartoon-like is a good way to put it. Imagine trying to simulate an entire city's traffic,
Right.
right? But the simulation only lets you program for like wooden carts and cobblestone roads.
Okay.
You can't really model modern cars and highways.
Okay.
That's kind of what some of these older economic simulations felt like. They were tailored to vastly simplified scenarios. You mentioned Google's AI Economist, which famously modeled a taxation scenario where agents just, collected wood and stone.
Right.
It's so far removed from real-world complexity
Yeah.
that the insights you get are, well, by definition, pretty limited.
So it sounds like they weren't just simplifying the individual bits, but also kind of failing to see how they all interplay.
Exactly.
Yeah.
Yeah. Beyond that simplification, these existing platforms often narrow the scope right down to just one single problem, like maybe only taxation or only market competition, which means they completely miss those crucial cross-domain interactions that, really define a real economy.
Right.
Think about how a new tax policy might interact with, say, changes in interest rates set by the central bank,
Yeah.
or maybe shifts in the aging population affecting pension systems. It's all connected. And previous tools just couldn't handle that level of interaction.
Right.
It's kind of like trying to fix one leaky pipe without realizing the entire plumbing system is interconnected. You might just end up causing a flood somewhere else.
And this is precisely the void EconGym is designed to fill then. It's acting as this crucial bridge between abstract economic theory and, well, complex real-world application. It's described as a modular, theory-grounded, and extensible platform. And its core contribution seems to be modeling both micro and macroeconomic dynamics using advanced economic theory, with explicit interactions among those four core roles we mentioned: individuals, governments, firms, and banks. Like the puzzle pieces, right? Explicitly linked. Exactly. And what's a key breakthrough here is EconGym's innovation. It features 11 distinct heterogeneous role types. So these aren't just generic categories. They include specific agents like overlapping generations, or OLG, households, central banks, even monopolists.
All right.
And each one is modeled as a modular agent with defined observations, actions, and rewards. This modularity allows for incredibly flexible composition of agents and tasks. It's truly like a sophisticated Lego set for economies.
A Lego set for economies. I like that.
Yeah. And plus it's scalable. It supports simulations with up to 10,000 agents. Wow. And just like a Lego set, the real power comes when you actually start building something. So how do you use this EconGym to construct and simulate an economy? It starts with selecting the roles, right? Like who's in your simulated world and what do they do?
That's right. You pick from a diverse set of roles and their specific types. So, for example, individuals aren't just one generic person. You have Ramsey model individuals who are essentially modeled as infinitely lived. This lets them project way into the future, giving insights into long-term trends like wealth accumulation and distribution across generations.
Interesting.
And there are the OLG model, overlapping generations, individuals. These guys actually age, which captures life cycle dynamics. And that's crucial for things like retirement policy, especially thinking about the financial well-being of an aging population.
Got it.
And both types of individuals, they make decisions on consumption, labor, savings, investment, and they interact with governments, banks, and firms. Then you've got governments. Also, more than just the government, you can have a fiscal authority setting taxes or a central bank managing interest rates and inflation, kind of actively steering the broader economy. There's also a pension authority managing retirement ages and benefits.
Okay.
And for banks, you can choose between simplified nonprofit platforms or more sophisticated commercial banks, which are profit maximizing and strategically set their own rates. And then, of course, you have firms. These influence output, prices, wages in the simulation. And they range from perfectly competitive types to monopoly, oligopoly, and monopolistic competition, each with its own unique way of behaving.
So once you've picked these roles, these Lego pieces, you then choose what algorithm drives their decisions. This is where the AI really comes in, isn't it? Can you walk us through the different ways these agents can think inside EconGym?
Absolutely. Yeah, for each of these simulated players, you decide how they think and make decisions.
Yeah.
And this is where AI really enters the picture, offering a whole spectrum of approaches. Reinforcement learning, or RL agents, for example, they learn by trial and error to optimize long-term goals, kind of like a player in a really complex video game figuring things out.
Okay.
Then you have large language models, LLMs. They generate decisions based on their internal knowledge, often exhibiting quite human-like behavior, almost like an economic chatbot, you could say. Behavior cloning, or BC, agents, on the other hand, they imitate real-world behavior. They learn by looking at empirical data, like observing how actual households make spending decisions from survey data.
Right, so using real patterns.
Exactly. You can also incorporate classical economic methods or expert rules, things like the widely used Taylor rule for central banks, or maybe the Sayers tax approach for fiscal agents, or even just human-defined heuristics. And finally, you can use real data policies, which basically just replay actual historical policies, like past U.S. federal tax rates.
And what's really fascinating here, you mentioned, is that you can mix and match these, create hybrid agents. So you could have like an OLG individual driven by real-world behavior data, interacting with a central bank that's following a classic economic rule,
Yep.
and maybe a fiscal authority that's actually learning through AI.
Precisely.
Yeah.
That flexibility is one of the core strengths. You can tailor the simulation very specifically.
Okay, so EconGym isn't just this theoretical construct. It sounds like a really robust test bed. Once they built this sophisticated simulation, what did they actually do with it? What happened when they let it tackle something as critical as, say, pension policy and an aging population? That's a huge real-world problem right now.
They did exactly that. Yeah. They simulated long-term population shifts and the effects of delaying retirement. They used 1,000 OLG individuals, and importantly, these individuals used behavior cloning policies based on real U.S. data, so trying to make them act like real people. And the results were pretty striking. Simulating different retirement ages, from 60 up to 70, show that, yes, higher retirement ages do boost GDP and consumption, and they significantly delay when the pension fund runs out of money. For instance, retiring at 70 delays depletion by about 15 years compared to retiring at 60.
Wow, 15 years.
But UT, and this is a big but, it also lowers social welfare and per capita utility.
Oh.
So this experiment really highlights that fundamental tension in policymaking, doesn't it? Achieving long-term economic stability often demands these difficult concessions in immediate individual well-being. It's a trade-off policymakers constantly face, and EconGym can help sort of illuminate its true cost.
That's a really powerful dilemma, the overall economic health versus individual well-being. So once they understood this trade-off, did they then sort of pit different AI strategies against each other to see how they'd handle it, playing the role of the pension authority?
Yes, exactly. They ran this battle of AI strategies. They compared RL, LLM, rule-based, and real data agents for that pension authority role. The RL agents, the reinforcement learning ones, proved superior for long-term optimization. They managed to sustain the pension funds for an impressive 165 years.
165 years?
Yeah, which is nearly 100 years longer than the agent just replaying real historical data.
That's incredible.
But the LLM agents, the large language models, they were actually better at human-centric objectives. They delivered higher per capita utility, so people were, on average, better off in the short term.
Interesting difference.
And the real data agents, well, they started strong but depleted the funds the fastest. So this clearly shows there are distinct strengths for different AI approaches, really depending on the objective you prioritize, long-term stability or immediate welfare.
That's a fascinating outcome. It suggests the best AI really depends on what you're trying to achieve. Okay, let's connect this to the bigger picture then. What happens when different government policies interact? You mentioned they looked at cross-domain tasks and multi-government coordination. What came out of that?
Well, jointly simulating the fiscal authority, the central bank, and the pension authority all at once revealed some really key insights. Firstly, coordination yields synergy. Combining just the fiscal and central bank policies together actually extended economic longevity and reduced inequality compared to them acting alone.
Okay, so working together helps. Makes sense.
But surprisingly, combining independently designed policies might actually cause conflict. When they put the full combo together, fiscal, central bank, and pension, using the standard rules for each, it yielded the weakest overall performance.
Weaker than just two. That's counterintuitive.
It is, isn't it? It really highlights a critical insight for real-world governance. Even policies that seem sound on their own, if they're designed without really considering their ripple effects across different sectors, they can unexpectedly clash and lead to worse outcomes overall. It's a powerful argument for needing more holistic, integrated policy design.
So if I'm getting this right, it's not just about finding the best single policy in isolation. It's about truly understanding those intricate ripple effects across the entire economic ecosystem.
Exactly.
And that means AI agents could enable adaptive synergy, right? Because the study found that just replacing the standard pension rule with an RL agent, an AI agent in that full three-part combo, dramatically improved the results.
That's right. Higher GDP, stronger government revenue, lower inequality, and stable welfare.
It's like having an AI conductor for the economic orchestra, kind of bringing all the different parts into harmony dynamically.
That's a great analogy. And this reinforces a crucial takeaway from their work. Pure AI policies, just letting AI run wild without any guidance, often underperform in these complex economic settings if they don't have what they call structural priors.
Structural priors, meaning
Meaning some built-in knowledge of how an economy fundamentally works. AI seems to be best when it's guided by sound economic understanding, rather than trying to learn everything completely from scratch in such a complex environment.
okay.
So these hybrid approaches, combining AI learning with foundational economics, consistently delivered superior results in their tests. And that's a really significant finding for how we might design policy in the future.
Got it. Hybrid is key. Finally, let's touch on realism versus efficiency. Can these simulations really scale up? Can they reflect large populations, like entire countries, not just 1,000 agents?
Yes, they showed EconGym scales remarkably effectively. When they ran simulations with more individuals going from just 10 all the way up to 100,000, the realism significantly improved.
Well, the simulation started to better match the empirical distributions we see in the real world for things like consumption and labor supply, and also for income and wealth inequality. It even reproduced classic economic patterns like the hump-shaped consumption curve, where people typically consume less when they're very young and very old, and more during their peak earning middle-aged years.
Right, that classic pattern.
So capturing that emergence is a good sign of realism.
So what does all this mean for us, for the listeners? It sounds like we're getting closer to having AI simulations that can genuinely reflect the messiness and complexity of our world, offering potentially powerful insights for policymakers and maybe helping all of us navigate the economy a bit more effectively down the line. This deep dive into EconGym has definitely shown us a powerful new tool emerging at that intersection of AI and economics. It really feels like a foundational testbed that can help us understand these complex systems, test policy ideas, maybe even design better ones, all without the real-world consequences of trial and error, which can be pretty painful. Yeah, and what's really compelling about this platform, I think, is how it combines rigorous economic theory with cutting-edge AI. It's not just about applying AI to economics in a sort of surface-level way, but truly integrating the two disciplines so they can learn from each other. That allows for a deeper, much more nuanced understanding of economic dynamics than we've had before.
And the platform is still evolving, right? They mentioned future plans to include even more complex stuff like local governments and international trade.
That's right. They're aiming to build out even more realism, which brings up a crucial point, really. If these AI agents, guided by economic principles, can consistently outperform pure AI and maybe even some traditional rule-based policies in these complex multi-agent settings, how might that fundamentally change the way societies approach policymaking in the decades to come? I mean, imagine the implications for your own financial well-being and the future shape of your economy if policy could be designed and stress-tested in these sophisticated virtual worlds first.
That's definitely something to think about. A potential future where AI helps navigate these incredibly complex economic waters. Something for you to mull over until our next deep dive.